The cost of running evaluations is the cost of knowing if you made a good investment. It will let you know when you are not making the right investment. And I think businesses would find that trade-off easy to make.
Hi, everyone. I'm Taqi Jaffri. I lead product for UiPath Enterprise Agents. And today I have Maria Vimer joining me from our product team.
Happy to be here. Hi, happy to be here.
Okay, so Maria, let's start with maybe a brief introduction. What do you do for UiPath?
So I work in product for UiPath, and I'm responsible for the reliability layer for agents, which is to say we work hard on an evaluations framework. And the goal for this framework is to tell the user if the agent is ready to go in production or if your deployed agents are healthy.
Wonderful. So when we say UiPath builds not just agents, but enterprise-grade agents, you're the person to talk to.
And you would be correct.
Okay. I think let's start maybe with framing the problem a little bit. If you could describe for everybody who's listening, what are evals? And as a person building an agentic automation, why do I care about evals?
Yeah, what are evals? You can start thinking about test cases. It's a familiar concept in traditional development. So you create test cases, you run them, and that's your scope. Agents evaluations go beyond that. So what you do with agents evaluations, you want to make sure that you're not only finding out if your agent is passing or failing at a certain point in time. You want to make sure that you have an overview of the entire loop. And when I say the entire loop, it means you have confidence that you're building the right thing and you can deploy to production, or evaluation is going to help you figure out what's happening with the agent once it's deployed.
Okay, so it's like a test case, but it's not just like a input-output mapping test case. It's even trying to figure out how the agent got from the input to the output. Okay, got it. Maybe I think an example would help. Let's imagine maybe an autonomous agent, which in the background is perhaps classifying Jira tickets and maybe even responding to them based on how they're coming in. If I'm a developer building that automation, how do I start? Maybe walk me through the journey, and how do I make that from, let's say, just a prototype to an enterprise-grade agent?
The most successful people that are building agents are also the people that know what they're building. So even if you're very much plugged into the business, that's great. If you're a developer and you're building an agent for someone else, you got to find out what exactly you're building. Because when it comes to evaluating what you're building, you do need a handful of good use cases. Those are going to be your golden set. You have to know exactly what you want the outcome of the agent to be, so the response, and you want to know the trajectory. What are the tools that are going to be called? What kind of context is the agent going to be plugged in? What are the escalations that the agent should be aware of? And not to mention, you're building an agent that might be part of a system, so you have to be mindful of that. To recap, you got to know what you're doing at the beginning to be able to create your evaluation set. The one that's going to be manually created, the one that you know that is good. There are 4 ways to build evaluations. So we talked about the manual building of your first golden set. As you move forward, your business might send you large files of use cases. You're going to have a bunch of data sets, which in reality are pairs of inputs and outputs. And if the input is what goes to the agent, the output is what is the expectation, what good looks like for whomever is going to be using the agent.
Got it. So in our example, maybe you have a ground truth data set of maybe 20 or 30 Jira tickets that a human has classified into, I don't know, in this working example, maybe severity level or by area. So you know those classifications are correct. And a human has confirmed that. So that could be like your data set.
Correct.
Okay.
And you can go even deeper, and maybe you're going to have corner cases when you want to escalate it to a human. So you have to define those conditions. Or when you want your agent to silently fail and avoid that. Maybe you want that because you're concerned with cost. And some of those Jira tickets, you don't have to be mindful of them. Maybe some other agent down the stream created them. So all these corner cases, they can be paired in really large data sets. You don't have to create all that manually. So we have import functions. So it's import, it's deterministic. What you have in that table, and someone worked hard to create them, and you trust that data, we import them, you're going to have them created in our product. Another way to build evaluations would be to simulate them, especially when maybe you don't have people in your team or yourself that really know corner cases that are unique. Maybe you do not know Japanese. So you might use a generation function to create that on your behalf at the beginning. Another way to build evaluations are from the real-time runs. So that means you have your agent and it's running in production. You know what it's doing and you want to pull from those live runs because they mean something to you. They're very important. Either the agent is doing a really good job and you want to preserve that, or the agent is failing and you want to pull that in, you want to fix your agent and use it and preserve it for the future to make sure that your agent is not going to drift.
Got it. I build my agent. I perhaps start by importing or manually entering some of these examples of correct behavior. Maybe I extend my data set. I love that Japanese example. Maybe I don't speak a particular language. So I sort of generate or extend my eval data set. And then I maybe deploy my agent to production or some test environment. And then I actually farm some real life examples of good or bad behavior and add those to my data set as well. Okay, wonderful. I think as you were talking, you mentioned something which was quite fascinating, which is, I want to drill down into that a little bit, which is these agents typically don't work in isolation. So they work as part of a system. So maybe you can elaborate on that a little bit. What do you mean if we have this testing analogy? Perhaps what you were describing so far was like a unit test, testing one component. But how do we think about end-to-end testing these complex systems that agents are participating in?
Yep, that's correct. So we were talking so far about the life cycle of evaluating one agent, but they're rarely going to work in isolation when you're deploying them in production. They're going to be part of a system. They're going to be an actor, part of a workflow. So if you're only focusing on figuring out how your agent is doing, you're only running evaluation for one agent, you're going to miss majority of the things that you're interested in. So what we are doing, we are thinking about evaluations for the entire workflow. So flow evaluations, which are end-to-end. That means your entire system, the downstream steps, actions that your agent or multiple agents are going to take down the stream, the conditional routing that the agent is going to take, that's going to be taken into consideration for end-to-end evaluations. So at the end, you're going to have multiple steps in a workflow, and each of those steps are going to have their own evaluation score.
And then also, I can imagine these agents are taking some actions which are, for lack of a better term, destructive, right? Like sometimes they're deleting a record or writing something to a database, and you may not want to do it for real. So how do you think about that for evals? Because in testing, we have this mocking capability, right? I think we have something like that for agents as well.
We do. So we do have a simulation feature, aka generation feature. And it's layered like a cake, I would say. So at the bottom, what simulations help you with is when you're testing the agent and you have one-off runs. Maybe you really don't know and you don't have an example at hand to feed to that agent. You can just simulate it. So in your example, we have tickets and we have a system you have to route. We want to route those tickets. You don't have to go and fish for a ticket from your system. You can just create one on the spot. You're going to use the simulation feature for that. When it comes, so that's a one-off test. When it comes to creating evaluation sets, sure, you can generate that. You can generate your data sets. But most importantly, the thing that you have covered are simulating the tools. And it's mostly because you have three advantages from doing that. You are avoiding creating downstream data that you're going to be on a hook for cleaning it up, and you don't want to do that. Two, it might be costly. You just don't want to run and have LLM calls for something that you're just playing with. And three, you might not have the connection yet to all those systems. So you just want to simulate it. You know what good looks like. You don't need to wait and have a dependency of your team to give you access to all those systems. That's going to speed your evaluation cycle.
Got it. It's just all about the iteration speed, right? You can kick the tires, experiment with something. Maybe you don't have a Salesforce connection or a Slack connection yet to your company's tenant. So you just simulate that connection and go from there. Wonderful. And I think there's also a point here to be made about the simulation being end-to-end. So connecting the fact that there's a simulation and end-to-end, because what if the first tool behaves a certain way and that causes failure in the third tool, right? So I think simulating the end-to-end journey using a model, a simulation model, is useful for that as well. Okay, another thing you mentioned while you were talking was cost. So let's drill into that a little bit. I can imagine this gets quite complicated and expensive with all these LLMs as judges and simulation LLMs. So how do we think about cost? Who's paying for all of this?
So when you think about cost, you're going to find out that cost is kind of attacking you on all fronts. You have a cost when you're creating an agent. You're going to be spending LLM calls to figure out the best prompt. You're going to be spending LLM calls when you're testing it, when you're running evaluations. And then once the agent is in production, you're going to be paying for the cost of the agent doing its job. So you might wonder, why am I doing all this? A good framework that I am using to explain why the cost is a good trade-off is you're actually figuring out if your investment is paying off. So the cost for
It's
paying
like an ROI calculation almost,
it's
right?
kind of an ROI calculation. So the cost of running evaluations is the cost of knowing if you made a good investment. If you have an agent in production and it's consuming but not delivering on a business goals, you would want to know that. So that's what an evaluation is going to do for you. It will let you know when you are not making the right investment. And I think businesses would find that trade-off easy to make.
Got it. And I think we can also select which LLM is being used to run your evals and which LLM is being used to run your simulations. I think that maybe also helps. You could use faster models or smaller models to do some cost trade-offs. And I think also, let's just close on something which I thought of while you were talking, which is, what if I don't have a great ground truth for something? So what if I want to evaluate something which is a little bit fuzzier? Is my LLM too verbose? Or is my LLM speaking in a business-like voice? So can I do these kind of runtime eval checks which don't necessarily have a data set attached?
Yeah. So you're touching on offline versus online evaluations. I think the industry is mostly aware of offline evaluations, which is pretty much the framework that we've discussed about. You need those data sets, you're checking if your agent is doing a good job, you're deploying it. Then what? If you do not have an outer loop that will continue to check what your agent is doing, then you can rely on just manual ad hoc checks, but that's not going to scale. You're guessing if your agent is doing a good job, not knowing. So that's what online evaluations are doing. You want to know if your agent is doing a good job without relying on humans proactively going back and picking and choosing some evaluation runs and just have this ad hoc method. So how can you evaluate an agent online when you do not have ground truth? You don't know what the agent is supposed to be doing because you don't know that specific use case. That's the entire reason we are using agents, because we want to feed them a variety of scenarios. Otherwise, it will be just a deterministic workflow. So in that case, there are evaluators that are looking at what agents are doing that do not need ground truth. Just to give a few examples, a faithfulness evaluator is going to do that for you. A context matching evaluator is going to do that for you. So you do have a handful of tools to be able to reliably figure out if your agent in production are doing a good job.
Okay, so I think that's a wonderful summary of everything to do with evals and simulations. Thank you very much, Maria. Is there a call to action? Can people listening go try this out today?
People can try this out today. We do have a free trial on our website. It's a 60-day enterprise trial. So if you're downloading our product online, you're going to be able to use it much like any enterprise customer out there. I would say if this is a call to action for a developer audience, everything that we've just talked about, like creating these evaluations, we have a CLI. So you can just run it in your coding agent of choice, and you can create all these artifacts by just prompting your favorite coding agent.
Wonderful. Okay, with that, thank you very much, Maria.
Thank you for having me.